Um, good morning, everyone. So, welcome to this CellStrat Hub API workshop, where we'll be deploying a question answering model using CellStrat Hub today. So, I'm Bhavesh, and I'll be leading you in this workshop. And yeah, so let's get started. So, before we start the hands-on part, let me just talk about a few things on the background. So the basic agenda for today would be to basically just talk about what CellStrat Hub API is, some background on REST APIs, and what an extractor question answering model is, and then we'll go to the deployment. So CellStrat Hub API is basically a deployment platform for to deploy any kind of API, any kind of AI model as an API. So it's all framework agnostic. So there are no strict format requirements or anything depending on the library. You can use PyTorch, you can use TensorFlow, you can use scikit-learn, anything you want, you can use. So it's all framework agnostic deployments. And you can deploy, if your code and everything is already, you can deploy it in under 10 to 15 minutes. And all the models deployed are serverless APIs. And that means you don't have a running server all the time for your API. So during idle time, it will go cold, so it will not be loaded in memory. But when you after some idle time, if you make a predict inference, or like if you call the API, it will get invoked and then it will get loaded in memory. So it's basically like on demand API sort of thing in the way, if you don't know what serverless is, but something of like that. So you only pay for the number of invocations and the compute time used, but not for the idle time. But in general, CellStrat Hub API is free for all. So you can deploy up to 5 model APIs for free, and per month you can make up to 1,000 API calls to your model. And because it's all serverless, so all the APIs are inherently auto-scaled. So you don't need to worry about any deployment infrastructure, and you can just simply focus on building your model. And just for your information, everything under the hood is a Docker container. So that gives you all the flexibility that you would want to change in your deployment if you needed to. But for most cases, for 95% of the cases, you don't really need to touch the Docker container at all. So you don't even need to know what Docker is, because everything is handled under the hood for you. So yeah, so this is CellStrat Hub API. But before we start deploying, we need to understand what an API is, because some might know what an API is, some might not. So just to level the ground up here. So a REST API, or any API in general, which stands for Application Programming Interface, is basically a way for two computers to talk to each other. So in this particular case, a web API is a way for a client and a server to talk to each other. So a client makes a request, and then the server responds with some other message or something. So generally, web APIs that we use all over in the internet today are all RESTful. RESTful, which stands for Representation State Transfer, is basically a set of design principles and design methodology and common patterns of API, those sort of things. It's basically a framework to design a web API. So all APIs that we have on the web are mostly RESTful. So the way all of these REST APIs are accessed is that we basically have like a base URL, or the location of the server where our service or resource is hosted. And then after the slash, we can add any of our own resources. So these are all called URIs. So this is a URL, right? So the entire thing is called URL. But the specific part after the domain is the URL. So let's say this is some user called Eve, and she has deployed some model called GPT Awesome. So that can be accessed by just going to this URL and then slash in the username and the API name. Similarly, if there's some Bob who deployed some model like Kool-Aid or something, and he can basically. So this is how you can access different resources on the server by using by the paths after the domain. So yeah, so generally, if you have any questions, feel free to ask me like where I'm going.
There is a question: what if CellStrat framework goes down because of technical issues?
So our entire stack is deployed on AWS. So mostly AWS is quite robust and resilient. So it's like 99.99% fault tolerant, I guess, according to AWS at least. So
See,
yeah, so mostly,
once you deploy it as an API, CellStrat framework is no longer in the picture. It is a API endpoint key, which is a core AWS service, right? So it's a Docker image on S3, and it is API endpoint key. So once you have deployed it, CellStrat framework is only active till you the point to deploy it. After deployment, it is you are interacting directly with AWS service. Am I right, Bhavesh?
yeah, essentially, yeah. Yeah, so we you don't really have to as such worry, but even let's say for some reason the servers go down on AWS side of things, then it's not just you whose servers is going down, but it's everyone who's gone down. So I think last month, I think in December, there was an outage in AWS. But yeah, but it was not just one person, it was everyone. So, but most of the time, like 99% of the time, the AWS doesn't go down. But even if it does, it just comes back up within an hour or a few minutes. Yeah, it's probably usually within an hour. Yeah. So yeah, so I hope that answers your question. So let's continue on with the HTTP request. So every request that you send, so I said that API, in an API, the client sends a request, right? So that request is basically an HTTP request. And the format of an HTTP request looks something like this. So it has basically the method. So there are multiple HTTP methods like post, get, put, patch, delete, and so on. And then there is the location where you want to send that request to. So the full API. So in this case, this URL that you're seeing here. And then the payload also consists of a header, of some headers. So headers are basically like metadata about the request. So they are not like the actual data, but rather some information describing the data. So for example, what kind of content is it? So this is an application, a JSON content. So the JSON is basically essentially a dictionary kind of format, dictionary list standard data types. And what kind of format will the client accept? So yeah, and authorization stuff. So in this particular case, Hub API, in CellStrat Hub API, we have a header called X-API-key, where you put your API key and then you basically call your model. And then after those headers comes the main body of the message. So this body is basically your input message or whatever you want to send to the server, so that then the server can take that message, do something, and then return back. So this is the basic format of a HTTP request. If you have any questions regarding API or any of those, feel free. So two particular methods that are relevant to us in CellStrat Hub API or can be used with any of your deployment is the GET request and the POST request. So GET request is a kind of request where you don't have a body. So in case here you see a body, right, or my own message that I want to send to the server. In GET request, we don't have that. We just directly call the server and then the server responds. So it's usually used for reading data from the server or something like that, or like pinging a server or situations like that. In our particular case, we'll use it to basically ping a model to load it into memory, because as I said, everything is serverless, right? So if your model is not active and is quite idle, it will get out of the memory and just stay dormant, and you would have to wake it up. Like you can directly make a prediction and also wake it up, but as a design choices, we thought of making a GET request way to load it up so that it's like an explicit call instead of a native call. So we start by making a GET request to the model, and so we don't send anything, we just call the model, we like ping the model sort of thing, and then the model responds like I am alive or something like that. So a GET request is this. So you don't send any data, you just get something in response when you make a request. In a POST request, however, so as seen earlier, we do have a body. So we do have some text here, some kind of JSON object here. And then we send it to the server, and then the server responds with some kind of output. So this is like a general input-output scenario. You send an input, you get an output. So this is a POST request. I hope everyone is clear on what a GET request is and what a POST request is. Yeah. Okay. So basically, let's see how CellStrat Hub API works. So in general, so when you you start by making a like after you make your GET request, the way you make a prediction is you basically create a POST request. So you have your X API key, you define the content type, and then you put your JSON object or whatever your input is here, and you make a POST request to your endpoint. And then basically that thing gets sent over from the client to the server, so the CellStrat Hub Inference API, and then the model basically does its inference, does some calculation, whatever the processing required. It does that, and then once that is done, it will basically generate the output and will respond with the predictions. So, and that in those predictions you will find the output. So blah 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 blah, and some other extra metadata as well. So on an overall sense, your architecture basically looks something like this. So you basically start by making a GET request to load the model in memory. So you don't send anything, you just ping the model and the model is like, yeah, I'm alive, and then it get loaded in memory. Then you make a POST request for input. So you send your input in a POST request, and in the response, you get your predictions. So this is a completely synchronous call. So asynchronous is not yet implemented. This is a synchronous call. You send a request, and at the same call, you get a response in real time. So this is how CellStrat Hub API works, and how you would make calls to it and all. Uh, Anybody has any questions or anything? Okay, so I hope everyone is clear on this. So yeah, so the model that we'll be deploying today is extractive question answering model. So extractive question answering is basically where we have two inputs. So we have a context. So this is like a paragraph or something, and then we have a question based on the context. So in school, in our English exam, we used to have reading comprehension test, right? Section A passage. So where we had a passage, and then we had a few questions that we had to answer, and the answers were from the given passage only. So extractive question answering is like that only. So we have a context and we have a question, and the answer to that question is some phrase or word or some line in the context itself. So as you can see, the answer to this particular question is basically this highlighted blue line, which is the answer. So this is extractive question answering. So the model is basically learning to find the start. Yeah, is the start, and jungle is the end of the answer. And then we basically get the the model is basically a kind of like a classification problem in a way. Like it has two classification heads, so it predicts two outputs, one for the starting point of the sentence and the second for the ending point.
So there are quite
So
a few
this
business use cases of this. Bhavesh, can you give some examples like
Yeah.
chatbots? What else?
Yeah. So for example, if you want to have a FAQ chatbot, for example, so you can use your documentation as the context, and the question will come from the user, and then you find the relevant answer from the documentation. So that's like a user manual or documentation use case. Other use cases include our general customer service and all as well. So again, it's kind of related to this only. And information retrieval as well. So generally, if you want to find some information in a bunch of docs, so what the architecture in that case would be, you first encode the document in some vector, you check the similarity of the question with that document, and then once when one of the document gets matched, then you use that entire document as the context, and then try to find the answer from that. So in information retrieval and all of those use cases, this kind of models can be used. Yeah. Um, yeah, so this is basically on what we are going to deploy today. So it's all a pre-trained model only. So we are not going to learn about building the model and training from scratch because this is a deployment one. So we already have the everything ready. So um,
Where's the
Okay.
documentation on the docs portal is updated, right?
Yeah, it's updated.
Okay. So very detailed
Yeah.
steps are there on the documentation portal, but anyway, today we'll be walking through it.
Yes. So everything that I'm gonna say today or show you today, everything is also on the documentation portal for your future reference. I'll just link it again in the chat if you missed it or something. But yeah, so you can refer that in general. And yeah, we'll also create a cheat sheet and all so that you can, in general, once you deploy your first model, you can like quickly deploy it. Like if you want to forgot something or you just want to refer back quickly. Okay, so in our particular kind of model, so in our thing here, in our model here, we have two inputs, right? So the red one is the input and the blue one is the output. So we have two inputs, the context and the question, and the answer is basically a string. So for how our API would be structured is, so again, this is entirely up to me, the developer. So there's no strict format, as I said. Everything can be, the model can accept any kind of JSON input. So it could be strings, it could be integers, lists, dictionaries, and all. So in this particular case, because we have two inputs, we will send our input as a dictionary. So we'll have a key as question and a context as a long paragraph or whatever. And then in our response, we'll basically get a string as the output. So all of this is like the metadata of the response. So like status code, headers, and all of that, invocation ID for your own reference. But the output is the one that the model basically returns and is here. So the request and the response both are to be JSON encodable. So that means you can't return a numpy array or any of those kind of things because those are not JSON encodable. So anything like the standard data types like we have, right? So strings, integers, floats, lists, tuples, dictionaries, and so on. So all these are generally JSON encodable. So yeah, so our particular model is going to work like this. So we send a dictionary of question and context, and then we get a string as the output. So our final output is the Berlin string. In this case, it's just a word. So deployment is basically done in 3 steps. So the initialize, the integrate, the build and deploy. So initialize is basically, so we'll actually do this in a hands-on. So as we go about it, we'll talk about it. So everyone can just open up their CellStrat Hub accounts and start the workspace. So anyway, it takes about 2 minutes to start. So just start that up and just let me know when you're all ready. And I'll also share you the notebook that we are going to use today. So everything is in a notebook, so you can directly run the notebook without using the terminal. But I'll as we go, I'll show you everything. So is this the same format JSON request? Yes, for all APIs, yes. So JSON. So everything should be in JSON format only, the request. So there are other kinds of formats that you can send in an API, right? So there you can send binary data, you can send files as well, those sort of things. But in our particular case, in CellStrat Hub API, it is to be JSON only. But you can send all of the other files also in JSON if you want to. You can just convert a file into base64 and convert it to a string anyway. But yeah. So I'm just sharing the link to the notebook. So yeah, so you basically download and upload this particular notebook in your workspace. So this is the link to the notebook. And just clicking on it will download it for you. Yeah, and just let me know in the chat when you're all ready with your workspaces. And meanwhile, if you have any other questions on the background side of things, so yeah, you can let me know that as well.
You can show in Hub how to upload it to Hub.
Yeah, I'll it's getting started. So yeah, I'm just waiting for it to get started.
In my case, it is saying invalid verification code. I just copied and pasted the verification code which I received in the email.
Are you
Sunil, just
sure?
send your
Maybe.
email. We'll verify in backend your account. Just
It
send
is
your.
the same email ID which I'm using to connect the uh, this Google Meet.
Yeah, can you please put your email in the
Okay, I will
chat
do.
for WhatsApp to Vivek?
Okay, I will do that.
Make sure there are no spaces or anything when we're doing the verification. And also you can try resend the verification code if you want to.
I'll try it again.
Sunil, your account looks confirmed. You can log in now.
It is just verified. Thanks.
Yeah.
Yeah, let me share my. So once you log in, you can click on the Start Workspace and then click on Launch Jupyter Lab once it's running. And once that is done, so just click on this Upload Files icon. So you see a Upload Files icon right here. So you can just click on that to upload the downloaded notebook. So yeah, so after I uploaded, you can see there's this notebook and just open it up and just let me know in the chat when you are ready. And
Will you please show it again?
yeah,
How to come to this window? I'm in the
yeah.
home
So
page itself as of now. I
yeah,
just
so you're currently in this particular page, right?
yeah.
So you can click on the Start Workspace button,
Okay.
and then it should in a few seconds it should turn into pending state, and in about 2 minutes it should turn into running state, and then you can click on Launch Jupyter Lab.
Okay. In my case, launch Jupyter Lab is disabled as
Yeah. So it's probably in pending or stop state, right? So you have to click on Start Workspace first.
start.
So yeah, on the left, the green button, Start Workspace.
Yeah, got it.
So everybody, please keep pace. You don't need AWS account here. With this system, there is no need to have any personal AWS or anything. The entire system, entire deployment will be managed within CellStrat Hub. So no cloud expertise is needed here. That is the advantage of deploying AI here. It will abstract the cloud complexity from you. So please keep pace with the workshop, because once you get left behind, then it will be hard to catch up. So step by step, please keep pace with the steps. Okay, shall we move forward?
Okay, so meanwhile it is starting, I'll just explain a few things. So once you open this notebook, you're gonna see a bunch of text and explanations on this thing. So this is the same thing that we just discussed right now in the PPT. So and this is also available in the quick start as well. So the first thing that we're going to do is, if you come down to the preparing model stage, so I'll just collapse everything. So when you're preparing our model stage, so this is the stage where you need to have your model ready. So in our particular case, we are going to use a question answering model, right? So you can start by just running this first cell, which has a few wget and all of those commands. So this will basically download the pre-trained model locally to your workspace. So just run this cell. And also, if you haven't set it, just make sure your kernel is set to PyTorch 1.9. So you can set the kernel on the top left, top right. You should see Python 3 or whatever, no kernel or whatever, but you can just click on that and make sure it's set to PyTorch 1.9. And just so you know, this is not just for PyTorch, it can be worked for anything. In this particular workshop, we are going to use PyTorch, but there's nothing PyTorch specific because we are directly using a high level library like transformers to do it. So it doesn't really matter which library it is. So yeah, so once your model is downloaded, you should see your QA model files here. So it has a bunch of tokenizer files and vocabulary and as well as the weight. So which is this bin file is the weights.
So what about H2O? Sunil is saying he uses H2O, but here he will be using PyTorch, which is already included here.
Yeah, but you can use any library as long as it's in Python. So yeah, if you want to use H2, you could. But this particular workshop, we'll be using this. So as I said, this is framework agnostic. It doesn't really, like the deployment with CellStrat Hub is not tied to any particular framework. It's a general framework. The only thing is that it has to be in Python. So like your code that you run should be in Python. But you can possibly run your code using Python using a C++ interface if you want to speed up things and optimize further. Yeah. So yeah, so once your model is downloaded, we'll start by checking out our model. So we'll just make sure our model is running. So we'll just make up normal prediction using the notebook itself directly. So you just start by import PyTorch and then importing the transformers, and then we'll load our model from our locally downloaded model. And then we have a sample context here, and then we have a question here. So just run that. And now we start by pre-processing. So we use the tokenizer, built-in tokenizer of transformers to pre-process. So so we are not going to go deep into how this model is working or anything. But just so you know, as I said, it basically predicts two indices. So it predicts the start index of the word and the end index. So like it's all a sentence, right? So it's all a paragraph, right? So this can be 0 index, 1 index, 2 index, and so on. So after tokenization, we basically use this index to extract the answer from this particular paragraph. So we start by we make the predictions, and generally the index could be either 0 as well. In those cases, it means the answer is not found. And even if like the end index is lesser than that, then that would make sense. Like it cannot start at Brazil and end at forest. Like it can start at forest and end at Brazil, but not the other way around. So those cases we'll just ignore if those predictions come in. And then we'll just decode the answer because so you can just see if you, just to show you. So the start index is 81 and the end index is 87. So it starts from 81th word to 87th word. And those words are from this input tensor. So your input tensors is basically contains all of those words encoded in numbers. So all the words are encoded as numbers. Yeah, and then we finally just decode the answer using the tokenizer. So as you can see, our answer in this particular case is Amazonia or the Amazon. So this is basically our model. So if you're deploying your own model as well, you would just check your prediction function. You will just create your prediction code basically. Essentially what we are doing here is just creating the prediction code, right? So we don't need the training or anything. We just need the part where we make direct predictions using some input text. So yeah, so we just do that. And yeah, so it's just because prediction is usually shorter, right? It's not like a long code, anything. So it's just a bunch of lines of code. And that is dependent on your model. So whichever model you're deploying, for this particular case, it's this. So that, yeah, so once, so you can run those cells and run this cell. So this preparing your model stuff cell. And then we can jump into the deployment part. So CellStrat Hub comes with a
So
command line utility. Yeah, sorry.
yeah,
Yeah,
maybe some people want a review again. Just check the messages.
so this is the notebook, and yeah,
And we are running it in cellstrathub.com.
yeah, so you cannot run this particular notebook locally on your system. It has to be run in the CellStrat Hub Workspace only because it's tied with the CellStrat Hub API. So, and yeah, and maybe it's your internet or something. Saying so, because that as well, but turns out it was my internet because when I changed, my internet worked normally. So,
So Honey, start from beginning again. That should fix it from maybe different browser. A
Oh,
different.
yes, I'm starting from like just refreshing it and logging it again because I think there is some issue in my system only. It's just got hanged meanwhile doing so.
Yeah, slow internet can hang it. So try changing Wi-Fi also. So everybody has reached just before deployment.
so meanwhile, I'll just give a background on what we're gonna do. So we have built a custom command line utility or a CLI called Hub. So this Hub utility can be accessed on the terminal. So if you just click on this big blue button on the top left, which is the launcher button, and if you choose the terminal here, and if you run Hub here, just Hub, you will see it is basically a CLI to deploy your models on CellStrat Hub. So it basically contains a bunch of commands that we are going to use. So in general, if you know about Jupyter notebooks, you might know that we can run terminal commands from the notebook also by prepending our terminal command using the exclamation mark. So just to put everything on the same page, like in the same notebook without having to jump around and all, we're going to run the commands from the notebook itself. But just so you know, generally, if you want to deploy model, you can use the terminal to deploy it. So you can run all of the commands that we're running in the notebook that are prepended by the exclamation mark indicating that it's a terminal command. We can run those commands from the terminal itself. So this is just for convenience sake, we are going to run the commands from the terminal. But generally, it's preferred to use the terminal because it's like the formatting and all is a bit more built for the terminal rather than the notebook. But yeah, but for now, this should help. And also, you can use the help flag on any of the commands to know. So just doing hub -- help will again open up the same page, the same thing. And if you, let's say you take a command, let's say we want to know about the build command. So you can do hub build and then -- help. And that will pull up a description of what the command does and what are the options available to you. Yeah, and similarly, there is for any other command. So in this case, we'll start with the init command, right? So you can just click on, you can just type hub init, hub init help, and then just it will give you a description of what the init command is, how to use it, what are the options available, and so on. Yeah, so the way we initialize a project, a Hub API project, is using the init command. So it's the hub init and then the name of the project. In our case, we are going to name it Extractive -QA. So just run that, And this thing, I don't know, because we ran it above these cells here, it's throwing that. But apart from that, yeah, you should see the project initialization at Extractive QA complete. And on the left in your workspace, you should see a folder created which says Extractive QA. I hope everyone's folder is created. Yeah, so if you just open that up, you will see a bunch of files and folders created. So let's take a tour of what each of those things is. So in our folder, whatever the folder is generated, so it's just demo thing. So you will have 2 folders and 2 files, and like just if you just go inside it, the Docker file is basically the configuration of the Docker image, and you don't really have to change anything here. It's automatically generated. It's all to be used directly. But just so you know, this is basically pulling from a hub-based API image, and then we basically install all the requirements for the API and just copy the source code. But nothing as such you need to know about it as such. But as mentioned earlier, everything is basically a Docker deployment. But if you do want to change anything specific in your Docker deployment, you can use this Docker file to change stuff. The next file that we have is the Hub Config Json. So this is just a JSON configuration file with the name of the project and the version. In the future, there will be other metadata as well, like some tags or description of your API, those sort of things. But generally speaking, this is the primary file, which basically defines whether a particular folder is a Hub API project or not. So whenever we run Hub Init, if we run this Hub Init again, it will say that the given project path already exists. So like basically, it's already a project. So generally, if you want to overwrite something like that, you can just do the -o thing. So that will basically overwrite it. So overwriting address, and you can see this. But yeah, yeah. So basically, this hub config is basically what indicates that it's a API. It's an API project, a Hub API project. So apart from those, you don't need to change anything here in the Hub config as well. It's all just auto-generated boilerplate files. So there are 2 folders which are primary to us. The model folder, which is an empty folder, but all your model files, so the models, pre-trained model that we downloaded, right? So we're going to put those model files in here. So all the model files or any of the large files that you have will go here. So this is so the contents of this folder will basically be uploaded to the storage servers. So not really with the model, it won't be together with the model, but rather be stored on a separate server for in a separate network file storage to be specific. But yeah, it will be stored there. That is because we want our Docker image to be small. So if we store the model files as well in our Docker image, then it will be it will not be very efficient. So the src folder. So we have a few files already generated here. So we have the main.py file. So this is the main Python file that gets executed when you call your API. So this has just a bunch of boilerplate text, boilerplate code, nothing as such. So just empty the question, but empty functions. But this is basically the function which gets executed. So you get your inputs here. So your JSON input. So if you designed your input to be in a dictionary format, you will get a dictionary here. If you send a string, you get a string. If you send an integer, you will get an integer. Whatever JSON input you get, that same exact input you will get in here in this particular function, the way that you send it. And then you do something with your model here. So you just add your prediction code here, and then you basically return the output that you have. And yeah, we'll talk about this particular thing in a second when we do the integration. But yeah, let me just go over the other part. So apart from the main.py, there is also a requirements.txt, which is again an empty file. But you will list down your libraries that are required to run the API here. So this could be like something like Torch, TensorFlow, or Transformers library in this case, and so on. So those things, we'll just add those lists down here. So you can add a particular version as well. So let's say I want Torch of, let's say 1.89, let's say 1.8, I can specify it like that. But generally, if I just want the latest version, I can just specify Torch. So just have to list down your dependencies. Nothing complex as such. And then utils.py is just basically an extra file, nothing as such to do. But if you're dealing with vision, this contains at least one extra utility to directly convert your base64 image to a pillow or numpy array. In this particular workshop, we're not going to use this particular thing, so I can just safely ignore it for now. But yeah,
So
but this is based, yeah.
So those who are familiar with Docker containers and Docker deployment, this is essentially providing a template for creating a Docker package to deploy. So it's simplifying the Docker deployment process basically by giving a ready-made package with fill in the blanks kind of architecture.
Yeah, exactly.
Can you explain Dockerfile again? This is a query.
Okay, so Docker is basically a way of packaging software. So generally, let's say I write some piece of code and then I send that code to you, and it may or may not run on your system, right? Because maybe you have different libraries installed, or even if you have the same library installed, maybe the version is different or something, or some or the other reason your code cannot run. So maybe I built my code in Linux, but you're running it in on Windows. So Docker is a way to package software in a universal format that can run anywhere. So it's like build once, build anywhere, deploy anywhere sort of thing. So you basically, it's like a virtual machine. So every Docker has an operating system associated with it. So usually we use the Linux operating system for all our Docker images because generally all of the software runs quite straight easily in Linux. So yeah, so basically we put but it's not exactly like a virtual machine. It's very much lighter than that. So it's very lightweight. It's in a few MB only, but it kind of emulates a virtual machine. So so you build your software and you put it in a Docker image, and regardless of who that person is or where that person is running the Docker image, the Docker will run isolated from the system that it's being run on. So because it has its own operating system, it has its own bunch of dependencies and libraries. So it can independently run anywhere. So that's basically what Docker is. It's basically a way to it's basically a way to package your software, your code, everything together. So your code plus the libraries, the dependencies, everything that is required to run that code, regardless of whether you have it installed or not. So the only thing you need to have installed is the Docker only. But apart from that, you don't really need to have your libraries, anything installed. So in this case, the Dockerfile. So when we build a Docker image, we define some things like where we are going to use it. So in this particular case, we are pulling from a Hub API base image. So it's like inheritance. So in object-oriented programming, we have inheritance. Like we import from, we use some base class and then build on top of it. So it's like that. So this API base image is again was built on top of the Alpine Linux, I think, or some I forgot like which one I used, but yeah, so some Linux only, and then on top of that we added some other, our own functionality, and then using that base image, then you are when you're deploying it, are adding something like you're installing the requirements, right? So whatever your let's say PyTorch or TensorFlow or whatever your API requires, you will install it, and then you're copying the source code to the respective folder. And then basically entry points is basically what you need to run. So when you run the Docker image, what command should be executed, like so again, this is fixed, so that's why it's like mentioned do not edit, because otherwise the model won't get deployed or run. But yeah, but that's essentially what a Dockerfile is. So Dockerfile is basically a blueprint of your Docker image. So it contains from the base image from where you are getting it, and then the other extra steps that you want. So each thing is a step here. So every line here is a step. So generally, you don't really have to worry about that or change that or anything. But it's just for your. But if you are familiar with Docker, then you could maybe change stuff. But even if you know Docker, you don't really have to change anything. There's no need because everything is automatically managed for you.
So there is a question here. Can I have any other software or database in your environment to support the algo?
Yeah, so because it's a Docker image, you can add your own extra database in installation. But one thing you should know is all your API deployments are stateless. That is, they don't, so your request and response are independent of every other request and response. So once you, so they don't maintain an internal state or anything. So if you want to maintain your own internal state, then you have to have a separate server where you use the API for the inference, but you store the database otherwise to maintain the state.
Or you
I
can
hope that
have,
answers.
a state management in client side and keep the
Yeah,
API
that's what I
calls
mean.
as independent
Yes.
web services.
Yes. So your API would be independent of all the other logic in your application. This is just a purely inference API. I hope that answers your question. Okay. Yeah. So let's move on to the integration. So this was I was just explaining about all the initialization. So initialization is just one step. It takes it's 1 second to run this command. And then we start by, so this is the step where basically our part as a developer comes in. So we copy our model files in the model folder. We add our prediction code in main.py. So in main.py you saw, right? So to do add your prediction code here. So we just add our prediction code here that we have already prepared here, right? So we had prepared our prediction code, all of this here. So we'll just add that there. And yeah, and then add our list out the libraries in the requirements.txt file. So we'll start by copying the model file. So in general, our QnA model files are these, right? So I can just right click them and copy them and then paste it inside the model folder. But of course, a faster way would be to just run a terminal command to do that. So we're just going to copy the contents of the QA model to the extractive QA/model folder. And it's copied. And if you check in your model folder, you should see your files there. Is someone speaking something? Got that. Okay. So yeah, so you just copy them. So and you can see all our model files in this model folder. So you can see our model folder here, right? So you can see all our files are here. So the next thing is changing this main.py file. So we have already opened this main.file. We have to add our own prediction code here, right? So what you can do is you can basically, yeah. Okay, so before we talk about adding the prediction code, let me just walk you through a few things here. So here in our main.py file, we have the import OS, some standard libraries and a hub handler. So this hub handler is basically a decorator, Python decorator, which basically kind of adds additional functionality to this function called inference handler. So you don't really have to know what it does or anything, but if you like, just for curiosity's sake, it basically handles your invocation and also handles the ping functionality that you will use to load your model in memory. But generally speaking, you don't really have to worry about that. But basically, all your code inside this function gets executed when you invoke your API, and of course anything outside that as well. So this global variables will anyway get executed. But on the function side of things, your source code that is inside this function will get executed. So your inputs you will get here. So your JSON inputs as in, and then you will return a JSON output only. So yeah. Apart from that, so we uploaded our model, we put our model files into a folder called model, right, in our source code, like in our project file here. So we had a model folder here and all our files here. So the way to access them from your source code is using this model dir environment variable. So in every operating system, there is something called an environment variable, which basically is a variable essentially. It has a name, it has a value to it associated with, but it can be accessed from anywhere. So all your API deployments have a model underscore dir environment variable, which is basically the path of the directory where your contents of your model is located. So so this particular model folder is there, right? So that path is basically equal to this model dir. So whenever you want to load your model and load any of your files from that particular directory, you will use this model dir as the base folder for that. So in our original code here, we were loading the model using our QA model folder, right? So now instead of that, we'll basically put model dir because that's the folder where our model files reside, right? So that's what we're gonna do. So yeah, so this is basically it. So we can you can open up your normal editor, Python editor, and add your prediction code here. But as I said, we are just going to try to put everything in the notebook itself. So in Jupyter, there is a function called write file. Also, just make sure you are CD into it. So just run this command. So all of the commands from here on that we are going to run using the Hub CLI you should be inside the particular project folder. So that's why we just change directly into it. Yeah. So write file is basically a way to write files. So you just write the contents of this file gets written to this particular file. So here we have our source main.py, right? So just so you know, I've commented everything that is added here. So just run this cell and just open this up again. So we see the updated code. So now you can see I marked all of the lines that we added from before were this. So we import torch, we import transformers, added this. This was already there. I just removed the comments. And we loaded our model here. So we load them as a global variable so that every time we are getting invoked, it's not getting loaded because that adds extra overhead, right? So we load our model and our tokenizer. So as you can see, we are loading from our model dir variable here. And then all of our exact code that we had here. So yeah, so we had our pre-processed code, we had our make predictions code and the decode answer code, right? All of that is as it is added to our function here. So nothing custom or anything. We just put all of our prediction code here inside this function. And then we basically return our answer. Our answer is basically a string, right? So that is also JSON encodable. So we can return those as well. So we get our inputs as a dictionary. So you can see we are just loading inputs question, inputs context, in our tokenizer, pre-processing, making predictions, blah, blah. And then finally, we just return our answer. So that is how you just basically add your own code to this thing. So that's it. So that is the integration step. So okay. Yeah.
Yeah, Bhavesh, I have a query here.
Yeah, sure.
Just want to elaborate my question, which I already asked before.
Yeah.
For giving the input to the model, I need to keep some historical data in some database, and I also need to get some real time data from somewhere, from some sources.
Mhm.
I need to merge them, process them, then I will give the input to the model to get the output. So for
Yeah.
that, I was asking, where will I store the database? The data
So those you need to
environment?
do externally only. So like normally in your client side or wherever you're having your application server or anything, you do all of that stuff there. And when it comes to passing the data to the model, then you invoke the API. Because as I said, it's stateless. Like, yeah, sure, you can have a database and all. You can maintain a database internally. But then it won't really be efficient because this particular deployment piece is only like good when you have is only good with a model, but not for stateful deployments where you need to maintain state and all. So those state maintaining you can do externally. So let's say I am
In
hosting
that,
my app. Okay, sorry, go on.
sorry. So in that case, Bhavesh, I need to do something at client side at in premise. Then I have to send that data to to your environment. Then it will be processed through. Then I will. It's kind
Yeah,
of okay. Not directly. I can't do everything at one place.
yeah, you cannot do like because there's also a synchronous API and there's a time limit of 29 seconds.
Okay.
So every processing has to be done within 29 seconds. And with those the DB and all of that, it will become very heavy and the cold start and also like technically you could do it, but it won't really be a very efficient or anything. And it will probably time out by the time it loads up all the DB and it becomes very heavy. So you want to keep our Docker image and everything minimal, as small as possible, so that
Okay.
our inference part is fast.
Mhm.
So in your normal code only, just add a API call in between for the processing of the AI part. So you have your application, you host it on, let's say, AWS or EC2 or somewhere. Um, the place where you do the AI part, you just call your API instead of having your own AI model hosted or whatever. So that way you will have a minimal deployment overall because now you're not paying for any GPU or any of those stuff. So
So if I have to do everything like that, then it's better to keep my model also at my local machine itself. Why to keep it
Yeah,
at
so
environment?
the advantage of that would be basically, so this API architecture is primarily suited, the serverless API architecture is primarily suited for microservices where you have everything in a distributed way. So let's say you are using DynamoDB or RDS or something in AWS, or you are using some kind of database in GCP or Azure. So you use that. All of those are interacted with APIs, right? So they're all serverless and they are all distributed. So and then you have the compute part in somewhere else. So in that, your inference API will just be another module in those kind of architectures. If you are
Okay.
doing everything as a monolithic approach, then maybe sure, you might be right. You might want to deploy it there itself. Although from a cost perspective and a management perspective, your own deployment will be much more complex than what we have here. And I think yesterday there was also another session on SageMaker, and I don't know if someone from here attended that, but I think you would have seen that how complex cloud deployments are generally are for AI models.
Yeah, yeah,
So it depends. Yeah, so it's basically to simplify the process.
okay. Thanks.
Just give me a second here.
Yeah, I was there on yesterday's workshop with Bismillah. Direct API deployment on AWS SageMaker. It is humongous task. You need a lot of cloud expertise and you have to enter your credit card and create an AWS account. So you literally need a cloud expert to do that. Here there is zero cloud expertise needed, and you'll be able to create atomic web services of various AI types for AI models.
Yeah,
So
I
each,
agree with you.
so each AI service is atomic. It's a standalone service. It doesn't maintain state. It's like a datagram protocol. Like you send an envelope to a friend and he does something for you and sends you back an envelope. But it doesn't maintain state, which you have to maintain in your client application. But this can be used to create a zillions of APIs for AI compute as a service very easily. Direct AWS AI deployment is extremely complicated, probably 5 times more, if not more, and extremely expensive also.
Yeah, you're right.
Yeah. So let's okay. Yeah, so yeah, I hope that all answers your question. And yeah, so let's yeah, so where was I? Yeah, I was on the main.py, right? So I hope no one has any questions on how we added our own code to this. So we just copy pasted our code in the inference handler function and added the loading model or whatever extra imports from our libraries are needed. So the next thing that you can do is we'll just add our two libraries that are required. So torch and transformers are required. NumPy is pre-installed in the Hub API deployment, so you don't need to specify those otherwise. We'll just run this, and if you open up the requirements.txt, you can see the two things mentioned here. So straightforward. So yeah, so that's it actually on integration. So 3 steps: you put your model files in the model folder, add your code in main.py, list out your libraries in requirements.txt. That's it on your end that you have to do. The others now, the again, our managed part comes in, so you don't have to do anything. You just run the hub build command. So make sure you are in, so you can run pwd to check you are in the right folder. So you have to be in an extractive QnA. So let's say I was not in there, so let's say I was somewhere else, and if I try to run hub build from there, it will say that the provided directory doesn't seem to be a Hub API project. Either change to the project directory or use the project path. So make sure you are in the right directory when you run the Hub build and those commands. So just run this command, the Hub build. So Hub build, what it basically is doing is it's doing two things. So one thing is you can see transferring model files. So it will transfer all the model files from your local workspace to the cloud storage. So that it's like, so all the large files and everything are stored in a separate cloud storage. And then after that, all your source code and everything is being packaged into a Docker image. So all your software, everything is packaged into one single Docker image, which has all the libraries, everything that it's required to run the model. You can see it's basically running the it's collecting torch and downloading torch. So it is not installing it locally, but in the Docker image, it is installing torch and all of those things. So. And yeah, so this can, so for the first time when you build something, so it can take about 1 to 2 minutes in a particular session. But consecutive builds, like if you make some changes in your code and then redeploy it, then it will be instant only. So because your everything is cached. So yeah, so just run this cell. So again, you don't need to run the CD thing because I think it's already run in the notebook here. So I'm just demonstrating it. So yeah, I hope everyone ran the main.py. So just make sure your main.py is not the original. So just check if all your code is there. And same goes for requirements.txt. Just check those two libraries are there. Maybe just so like you ran these two cells, right? So this thing and this thing. So using the write file magic function. And you can ignore these warnings. This is because it's being run as root. So, and some libraries are already there. So it's basically saying NumPy already exists. So as I said, yeah. So you can just ignore those warnings and just wait for it to run.
So Bhavesh, I went all the way to the end and I put my API key username, but it's showing forbidden response.
Did you specify your username and your key?
Yes, I did.
Just make sure your key is correct. Like make sure there are no typos. Just try it again.
Your API key. No, earlier I gave the wrong key, so it was saying not able to find. Then I gave the key ID. The key ID.
No, not the key ID. You have to give the key itself. So.
Oh, the key itself, not key ID.
Not key ID. So this key
Okay.
here. So which is the copy thing.
Okay.
Yeah. So yeah, so once this is built, so you can just run the next cell, which is the deploy. So this will basically push everything to the cloud. So model files are already to the cloud. This will now push the Docker image to the cloud and deploy your model as an endpoint and create all the necessary resources, all the infrastructure resources that are required for this. So as you can see, it's just basically uploading all the files. So again, this process again can take 1 to 2 minutes. So overall, if you have your code ready, this can take under 10 minutes only. So this integration is just 1 minute. Copying the files is another few seconds. Init is just another second. So yeah, overall, I guess less than 5 minutes in total. Like if we talk about the deployment process itself.
So Karthik is saying he cannot create API key in the API dashboard.
So you can click on create API key, and after you have deployed some model or anything, just after that do it, because otherwise if your models are not there, it might or
Yeah,
may not.
I tried that, but that window pops up and then it goes off.
We just refresh it. So your deployment is complete. Have you deployed your thing?
Yes. Yes.
So it says deployment complete.
Yes, it says
Okay.
deployment is complete.
Okay. So
Model deployment
just
complete. And, yeah, that I'm able to see the text message from that.
So when you click on create API key, are you able to see your model, whatever, and just check that and click create key?
Yes.
Then just refresh.
Buffering thing happens and then that window vanishes and I could not see anything in the key ID or API that.
Did you try refreshing your page or anything?
Yes, I tried. Whatever you asked, that API key, I'm not able to see that. Entire table is empty for me after doing that create API.
Just sign out and sign in once, maybe.
Okay.
I'm getting 500 error when I enter key.
Yeah, once again, I'll just show you how it all comes together. 500 internal AI model error, right? Probably, or something like that. So make sure you have all run the cells as in the right order. Right order as in basically you have followed all the steps. So you copied your model files, you put everything in the integration.
Sir, I got the message forbidden at the end. What should I do?
What did you get? Sorry.
Come again. Who was speaking?
Sir, I executed the full program. The deployment was complete and all the code blocks were executed. But at the end, I got the message forbidden.
Yeah, did you? Yeah, so you need to put your API key and your username here. So yeah, I'll just come to that point. So once my deployment, yeah, okay, my deployment is complete. So the first thing is you need to go to your deployment dashboard. So with the link that you can see, or you can just click on deploy models to come here. And you should see an API key. If you don't see one, just click on create API key. And then basically, I think it should also be by default, there should be one API key. But yeah, but basically create, okay, let me just refresh it. So you can, for the first thing, so you can see your model deployed here. You can see Extractive QA here deployed in under model APIs. Just click on that, click on the copy API key. So let's click here to reveal API key, copy it, and then paste your API key in the API key variable here. Now go to your profile. So you can click on this link here in the to go to the profile, or also in your profile here. So if you don't remember your username, so this is my username. So this is the one that you set yourself. So when you first logged in or whenever, or when you signed up. So just put that particular username here. And yeah, and then basically run this cell, the first cell. Then we will basically make a GET request to basically load the model in memory. So this will take a minimum of 20 seconds or somewhere around 30 seconds to do so.
Okay, sir. Thank you.
Because everything is authenticated. So you need an API key. So the point of an API key is so that it cannot be misused, because you can probably see that you have about whatever, I think in the free tier, it's 1,000 API calls per month. So for the particular month that you are in. So these API keys are basically what determine how much you have used and how much it is left. So, okay, so 1 second. The level updated proposition, consider increasing your provisioning level with the okay. I'll just try it again.
Hello.
Yeah.
Beside Honey, I was asking one thing that mine is still running this hub deploy, and it is
Mhm.
showing that deploying your model as an API, updating existing deployment. So it is not proceeding from this line. So I have
Yeah,
done it, but
like it.
because
Uh,
yeah.
um,
No, it,
yeah.
it took me,
So
it took me 5 to 7 minutes, 5 to 8 minutes for me. So
Okay.
it does take a long time. Yes, it's not 1 minute, it's 5 to 8 minutes it took me.
Okay. Okay. Then I shall wait here. Then I shall. Okay. Thank you.
Next to PyTorch 1.9 on top right, you'll see a blackened circle. So that means it's still running.
Yes, yes, yes. That's what it's showing.
And at the bottom also, you can know it is whether idle or busy or whatever. The person was saying not able to create API key. Were they able to create one?
Yeah. I just logged out and logged in, but still after that also I'm not able to do that.
Okay.
I'm trying once again now.
You can try the existing API key already there. There might be one of them, no?
No, it's not there.
Okay, like maybe you might be a old user, maybe, because back then it was not default. It's just updating. Actually, I just changed the DynamoDB to on demand because I guess the provisioned capacity. Okay, yeah. So meanwhile, I'll just go over what all the other steps are, just so you know. So we make a GET request to load our model, and you can say model loaded in memory. So yeah, after that, we can now, once it is loaded in memory, we can start making predictions. So let's say I have this context and question. I can put my question here, the context in the dictionary format. So you can see I put a dictionary here, and then I make a request.post with the endpoint, the headers, and my data, and then get a response. Yes, as you can see, I got my answer as Amazon or Amazon Dipper. And if I, let's say, talk about what is Amazon forest called in Portuguese, I don't know if it will do that, but let's try it out anyway. So you can see Floresta Amazon, I think, yeah, from here or wherever it was, yeah. So you can see, yeah, so it's working, and you can also see, because it's time, you can see the time it took to run that. And yeah, so this is essentially it. So again, this is just a way to test the API in Python. You can generally APIs can be invoked from anywhere, right? So it's language agnostic. You can invoke APIs from Java, you can invoke from C++, you can invoke from JavaScript. Generally speaking, it's usually we use it from a web application to basically use it. So usually have like a web application or something on the clients on the front end, and then we make our invocations from there. But yeah, it's not just for client side, but it can also be run from server side or any of your own architectural distributed systems or anything. Yeah. Karthik, can you share your account email? Let me just check what's the issue on your end.
Sure.
If you're not able to make it still.
I continue to get 500 error.
Then I guess you'll have to check your logs. So generally speaking, the way we check, let's say here we are getting some error, right? Some 500 error or something. So the way to check that is basically you can run hub logs and the name of your project to basically view the logs of your model. So this is how you can debug basically your model or just get the logs and all. So you can see I had a print statement, so I don't have any errors as such, but I can see the duration, the actual inference duration that it took apart from the round trip times for all my invocations and all. So we'll say you can run the hub logs and the name of your project to get the logs of your thing to see what the error is.
One observation, Karthik here, when I try to click the deployed models and see the logs, then the execution logs runs, and then the entire screen goes off. Says unexpected error.
Yeah, I have the same error. I can't see logs online, but in backend some logs came up using that bell command. Online the log screen is crashing. Yes.
Yeah.
I've just texted my email ID.
Yeah, okay, yeah, sure. Let me just check. And anyone else whose models are running, have just let me know if your model is successfully running and you're able to getting the answer or whatever after putting your API key and username. And if not,
So
then
it
just
is
let me know.
running, but sometimes it is giving quite funny answers.
Yeah,
Like,
it's the AI model. Yeah, so
yeah.
you can try with different contexts and everything. So it's the AI model. So depending on the training, can give whatever answer it seems fit.
So it will also show on my Hub API dashboard, right?
Yeah,
So in
like once it's
the like yeah, at the bottom it will be it showing like deployed model APIs.
yes,
Okay, so that means that it has been done.
yeah.
Okay.
Well, so what was your logs from the error? Were you able to figure out the error on your end? So the key seems to have been generated for you, Karthik. I think I can see a bunch of keys. In fact,
Okay.
9 keys generated.
Okay. So
Maybe just on the UI front, you're not able to see it. Are you still not able to see it?
yeah, let me refresh the page now.
Or maybe try using your phone to just see it, like if maybe like with your phone internet or something. Because on the back end, everything seems fine.
Bhavesh, if I redeploy from beginning everything, will it cause any problem redoing the
Uh,
entire process?
no, it won't. You can start from the beginning. Although just the init part, you might want to use the -o to override and like you override the code. So in the init part, okay, where's the init? Yeah, here you just add a -o, and that will
Okay.
basically override
Okay,
if you
okay,
want to like start from scratch. So
okay.
Also, you can actually test your API on this web app. So just go to this web app that I put on the link. So it's basically a front end apps just so you can test this particular API apart from the code, just so you know how it looks if on a front end on an application. So you just put your username here, and then put like as you can see username / API name. Someone's speaking because I can't hear you. Karthik, I can't hear you.
Okay, I just refreshed the page, but still not able to see the API.
Huh? Okay, one second. I'll just send you the API key like from the backend for now.
Yeah, no problem.
Okay, I'll just send it here. And yeah, in the chat.
Okay,
But
then I will just try running the model.
Just that API.
But maybe offline we can check why it's not.
Yeah, offline you can send me a screenshot and like I'll want to actually know the front end log. So
Sure.
You can contact offline and
Sure.
as well as on the Discord if you want. Yeah, so just put your thing here, your username and the API name. Put your API key here. So I just copy my API key and then put the context. So let's try to fetch something from Wikipedia, I guess. Can we? Okay, let me try something from the docs itself to see if it's able to answer. So I'll just copy this thing. I guess I don't know if emojis would work. I'll just remove the emojis. I have some context here and I can ask how long does it take to deploy a model? Okay, before, let me just load the model. So you can click on this load model to basically make that GET request. So you can say loading model into memory. Please wait for around 30 seconds. Is everyone able to use the client application, the front end website that I shared on the chat, the Extractive QA thing? So, and if anyone's curious on the source code, you can find the source code. So I don't know where I put that source code again. I think it's my GitHub. So let me just pull that up. So the application source code you can find on my GitHub. So if you are, if you have done web development previously and are curious on it, so I'll just put it on the chat. But before that, okay, let me also predict the answer. Yes, so you can see under 15 is the right answer. So under 15. Although I think it should have said under 15 minutes. But yeah, whatever. Oh, and I think I probably know why. I think I always have to maybe put +1 here. Yeah, so in the source code, I'll make one change. Yeah, I think this end the index is equal to end index +1 should always be, because I think the end index that it's predicting is inclusive, but generally in Python when you do indexing it's exclusive, right? It doesn't include the last thing. So let's run that again and redeploy it. And as you can see, like because I changed the source code, it's going to redeploy, but it won't really take that much long because everything is cached. So you can see it's built, and I just run it again. And again, the everything exists and it's just directly to updating existing deployment stage. Yeah. So okay. So okay, let's just wait for this. Otherwise, yeah. So just a few things that needs to be considered. Is I think already as mentioned, these are all synchronous in nature. So it's not like so it's as you send the request, you're going to get a response immediately. On the other side of things, it's also stateless. So again, someone had asked the question and we talked about that as well, right? So it won't maintain an internal state of your inputs. So every request response cycle is independent of each other. And some other things is basically also you have a 29-second time limit for your prediction. So this is currently not suitable for batch inference yet. So this is for synchronous real-time applications only. It's in the roadmap. So the batch inference way where you can make inferences for longer time, like let's say for hours and hours. So that is in the roadmap. But at this particular moment, the current API that you are using right now is not for batch inference as such. And yeah, and generally you can go check the docs in general to read more on everything. And some previous webinars on the same API was also done. So there was a vision clip model deployment also uh, previously, I think a few weeks back. So you can check those old recordings as well. And this particular recording will also go in this page as well. And also, and of course on the YouTube, because like from YouTube only, it's going to be linked. And yeah, feel free to subscribe, and we're going to have much more content on YouTube from now, from soon. Yeah, so is it deployed? Yeah, more deployment complete. Let's just note the model. Yeah, so that is it essentially. And apart from that, do join our Discord as well, because if you want to ask any questions, have some further discussions on this, you can feel free to join the Discord community, and we'll also be having other events as well on the community, like weekend hackathons and like ML Tuesdays, where we have like exercises do exercises in deep learning or machine learning. And yeah, so we'll have we have a bunch of other events as well. I think this Tuesday we have a ML Tuesday coming up. So do join the Discord. I'll share the link on the chat. And yeah, so this is essentially it. And I think if I reload this, if you reload the application, you should see the get source code button there now. You can click on that if you want. If you have done web development before, you might want to take a look at how the API is being integrated and used in a web application. So it's built with React and Next.js. So if you are familiar with that, you can check that out. But yeah. Yeah, so under 15 minutes. Yeah, so any other questions anyone has?
So would you please share the GitHub link in the chat?
Yeah, it's basically go to this thing and click on get source code, just refresh your page. Otherwise, also I'll put it if you are interested in web development. And is there anyone whose deployment is not working or are facing any kind of issues?
Yeah, I can't fix the 500 error, or both on get and post.
Okay.
I can give you my password if you want.
Let's.
You can
I
do it
guess
later. We
you
can
can
do it
just.
later also. Yeah.
Yeah. Offline, I'll talk to you and we can figure that out. Anybody else who has any issues?
Even have that same issue with API key is also not, whichever you share, that's also not working. Maybe offline, I can check with you either in Discord or WhatsApp.
Yeah. So yeah, offline, as in, are you on WhatsApp or are you on Discord or something?
I'm on both.
Okay. So yeah, so just ping me on Discord or something and join. We can join some lobby and you can share your screen and we can fix that up.
Sure.
Yeah, and everyone else, are your models working fine? everybody else on the call here? Okay, great. And web app is not working. I'll just refresh your thing. I don't know. It was working for me. Just try refreshing it or something maybe. Did you put your username prop and API name, the API key and everything? Just make sure you do that. Yeah, so that is it mainly for today's session. So I hope you yeah, great if you're able to pass your own passage and try to Q&A. And if you have any other questions, you can come out on the Discord. I'll just share the link again if you might missed it. So any questions regarding deployment or any doubts or just general discussion or any particular thing, just come on the Discord and we can chat there. I'm always active. I'm 24/7 active on Discord, so you can anytime ping me. And yeah, so yeah, this is that is it for today. So I hope you enjoyed today's session and you were able to deploy a model, and I hope the deployment process was straightforward. So apart from the explanation, I think just the commands itself. So just init, add your own code, build and deploy. I hope that was easy enough. And in general, if you have any suggestions on how to make it easier, or if you found something difficult or complex, feel free to share that feedback as well. In your deployment dashboard, you can actually see a feedback form thing, I guess. Yeah, I think in your deployment dashboard, you can see a yellow orangish color button which says feedback or report bugs. So you can go there, or of course on the Discord as well apart from that. But yeah, so thank you everyone for joining, and yeah, we'll see you maybe soon again over next weekend or something, and we'll do something else as well. Yeah, so thank you everybody for
Okay, so audience,
joining.
any final questions? So if you are facing trouble, reach out to us offline. We can help you out with the deployment. Okay, one-on-one. Okay, then thank you all for joining. Thanks, Bhavesh. Very good workshop. Thank you.